Good afternoon, good evening. We're going to talk about the domains of functions today. Let me start by taking a look at this Word document that I've posted online. It talks about what domain actually is for a function. Now, I know that a lot of us think of the domain of a function when we think of a graph, and that means that how far does this graph extend to the left, to how far does it extend to the right. And that's one understanding of what domain is. But there's another idea that we want to focus on if we're not given a graph. What if I just gave you an equation and I said, hey, what's the domain of this function? Well, take a look at what my definition of domain is. The domain of a function are values that when you plug them in for x will produce a value for your y. Okay? Now, in most cases, our domain will be all real numbers. Because mathematically, is there any type of math that you're not allowed to do on particular numbers? And that's going to be our focus. All right? Let me jump into the smartboard here now, and let's take a look at what I'm talking about. All right? Suppose I have a quadratic function, a parabola. Suppose I have f of x equals x squared plus 3x plus 1. Well, what math is happening to my x to get my y value? Well, let's see here. I'm squaring the x value. I'm multiplying the x value by 3, and then I'm adding a 1 at the end. Are there any values in this world that you're not allowed to square? I don't think so. I'm allowed to square every number that I want. Is there any number in this world that I'm not allowed to multiply by a 3? Well, again, I think I can multiply every number in this world by 3. And then lastly, couldn't I add 1 to any number in this world? So in this case, for this parabola, our domain is unrestricted. In other words, I'm allowed to pick any number that I want for x. So it's all real numbers. So my domain would go from negative infinity all the way to positive infinity. Similarly, suppose I had a line. Suppose I have f of x equals, say, 3x plus 5. Well, again, similarly, I'm allowed to multiply every number in this world by 3, so I can plug any number I want in for x. I'm also allowed to add 5 to any number. So in this case, my domain would be unrestricted. I'm allowed to use any number I want for x. And don't forget, domain is what numbers are you allowed to plug in for x. So the question is, are there any red flags where we're not allowed to plug any number I want in for x? Well, you need to think back to your arithmetic days and pre-algebra, and the first red flag that I can think of that you guys came to were things like this. If I have a fraction such as 7 divided by 0, well, you guys learned that this is undefined. Now let me show a little bit of why that's undefined. All right, and this is my basic explanation of it. Division. Well, if I take two numbers and I divide them, like 6 divided by 2, well, we know the answer is 3. Well, if you look at this, if I multiply this denominator times my answer, shouldn't I get back to my numerator of 6? 2 times 3 is 6, so it works. If I take something like 20 and divide that by 4, what's the answer to that? The answer is 5. Well, why? 4 times 5 gets me back to 20. Even if I take 0 and divide it by 6, and I get 0, well, if I take 6 and multiply it by 0, don't I get back to 0? So these are all okay, but what happens if I take a number like 8 and I divide it by 0? What could I divide 8 by and get 0? What answer could I get here? Well, a lot of you are probably thinking 0. Well, but wait a minute. Does 0 times 0 equal 8? Doesn't work, does it? Well, what about maybe making it into a little 8? Well, wait a minute. 0 times 8 is 0. That's not 8, so 8 doesn't work. And in fact, there is no number that's defined that would ever give me the numerator of 8. So this is why this fraction is undefined when 0 is in the denominator. Well, that being said, what happens if I have a variable in the denominator? What if I have something like this? What if I have, say, 7 over x minus 3? Is there any value that would make this denominator 0? Is there any value of x? That's right. If I plug a 3 in for x, get a 0 in the denominator, right? And that's no good, right? So if I was allowed to plug numbers in for x, I could plug in any number that I want except for 3, right? So the first red flag that we need to focus on is if I see an x in the denominator of a fraction, I need to make sure that whatever that x value is in the denominator doesn't give me 0 in the bottom. And that's this first restriction right here. Restriction 1, x in the denominator of a fraction, you need to avoid 0, okay? All right, so let's take a look at another example here. If I have this one, if I say in this problem right here, f of x equals, say, 7 over 3x minus 5, right? Well, what value would make x, or would make the denominator 0? Well, couldn't you just say, set the bottom equal to 0, or not equal to 0? I don't want it to equal 0, and I could solve, right? I would get 3x equals, can't equal 5, so x can't equal 5/3. Because again, if you plug 5/3 in for this x, that's going to give you 0. So my domain for this guy would be all real numbers but 5/3. So it would be anything to the left of 5/3 and anything to the right of 5/3. In other words, greater than 5/3, but not 5/3. Because of that, I need to use parentheses to show that I don't include 5/3. And because I have two different answers, I need to put that yin-yin in there between them. So my domain here would just be negative infinity to 5/3 and 5/3 to infinity. Okay, let's take a look at the next red flag. The next red flag is something that we've been talking about recently, and you've talked about in the past, and that's square rooting numbers. I know that the square root of 25 is 5. I know that the square root of 0 is 0. And I even know that the square root of 12 can be simplified into 2 root 3, or approximately 3 point yada yada yada. I can get an answer. But what about the square root of negative 4? Now I know that we've talked about imaginary answers, but with domain we only care about real values. So you never include imaginary ideas when it comes to domain. Well, in that case, what happens if I have an x inside of a radical? Well, it depends on what kind of radical. Take a look at this. If I have f of x equals, say, the square root of x plus 1. Well, let's see here. I know that the radicand, this whole thing, this guy, must be greater than or equal to 0. So if I solve this, I would say x plus 1 has to be greater than or equal to 0, so x has to be greater than or equal to negative 1. I know that my domain has to be any number starting at negative 1, including negative 1, and numbers greater than that. Okay? And let's just check it out. If I plug a negative 1 in for x, negative 1 plus 1 is 0. I'm allowed to square root 0. Let's plug in, say, something like 0 for x. Well, let's see, 0 plus 1 is 1, and I'm allowed to square root 1. If I plug a 1 in for x, well, let's see, 1 plus 1 is 2. Can I square root 2? I can. I don't know what the answer is. That's an irrational value, but it is square rootable. So that's why this domain is anything to the right of negative 1, including negative 1. Let's take a look at an example that doesn't work. If I plug a negative 2 in for x, well, what's negative 2 plus 1? That's negative 1. Square rooting negative 1 gives me an unreal answer. So negative 2 would not work. So it makes sense why the domain in this would simply be from negative 1 to infinity, including negative 1. So in general, if I want to find the domain of an equation that has a square root around an x, then let's take a look at this. What I need to do is, in restriction 2, if I have an x inside of an even root, I need to set the inside of the radical greater than or equal to 0 and solve that. I've got a couple more examples here. There will be a homework assignment called Domain Worksheet A that I want you to do the first 4 problems of tonight. Thank you. I'll see you tomorrow.